In this course, the fourth in the Quick Start series, I'll show you how to create a simple assembly consisting of 3 components. We'll also add balloons to the assembly and design a bill of materials based on a custom report style. In the first video, we will create a 3D assembly of the crank handle using ready-made parts. Click the assembly icon to create a new assembly document. The assembly environment looks similar to the part environment, with a few exceptions. At the top you can see the toolbars intended for assembly design. Right-click the assembly in the tree to adjust the model properties. Here you can define the designation and name of the assembly. Confirm the command. Save the document in the folder where the assembly parts are stored. Let's add the first component to the assembly. Click Add a component from a file in the Components toolbar. This opens the Selected a Component source file window. Select Connecting Rod and click Open. Ensure that the Fix option is turned on. This option allows you to fix a component in its position. Now you need to position the part. The part origin should coincide with the assembly origin. You can either enter the coordinates for the part origin in the Parameters toolbar or use the snap to place the part at the origin. Follow the snap symbol and click to place the part. Confirm and stop the command. The component section has appeared in the tree. If we expand it, we will see the rod. Note that I can't move the component because of the Fix option. You can see a pin symbol next to the component name in the tree. Let me unfix it to see what happens. You can find the unfix command in the Components context menu. But now I will use the Sort field. When you enter the first letters of a command name here, the system will suggest relevant commands. Now I can move the part anywhere I want. I'll undo and return the component to the fixed position using Ctrl-Z. Click Add a component from a file to insert the next component. Select Shaft. We need to define how to place this component. We can use the by-mating method for this. It opens the Model Source window. This window allows you to analyze the component and choose elements for mating separately from the assembly. Let's analyze. The cylindrical surface of the shaft should be welded to the cylindrical surface of the connecting rod. The blue plane of the rod is the symmetry plane, like the blue plane of the shaft. We will use these features to precisely position the components. The first mating we apply will be coaxial. We define that this cylindrical surface is coaxial with this shaft surface. Notice that the surface names have appeared in the object fields. You can reverse the component's orientation using this option, but we don't need it in this case. Confirm. Click Coincidence. Select the rod's blue plane and the shaft's blue plane. Confirm the mating creation. Confirm the component from file command. The command will prompt you to add one more shaft. Decline. Take a look at the tree. There is a minus next to the shaft. This means its position isn't completely defined. You can verify this by trying to move the component. The reason is that we haven't restricted the shaft's movements in all the directions. Let me stop the Move Component command and fix this. Double-click the shaft in the tree to edit its placement. Apply one more coincidence mating to the ZY planes, the red ones, of both components. The shaft has moved to the only possible position. Confirm the coincidence and the component's placement. A plus sign has appeared next to the shaft. Insert the last component in the same way. Select Arm. Activate the by-mating option. apply the coaxial mating between the cylindrical face of the arm and the cylindrical face of the shaft. Check the reverse orientation option if you're not satisfied with the arm's placement. Confirm the mating creation. Next, click Coincidence. Select the planar face of the arm. If you make a mistake, you can delete the incorrect object and select the one you need. Select the planar face of the shaft. The arm has moved to the desired position. We could add one more mating to restrict the arm's rotation and completely define its position. But we won't do that, since the component is symmetrical, and this rotation won't affect the assembly design. Confirm and stop the command. You may notice a minus sign here, but we allow this. The assembly is finished. Note the symbol that indicates you need to rebuild the assembly after editing. You can click Rebuild in the Quick Access bar or just save your model, and Kompas will prompt you to rebuild the model. Let me click Show All to fit the model into the screen.